6.3 Numerical Model. There are many different ways biomechanics can be used. For example, someone might use biomechanics to analyse the body position of a basketballer and also the amount of power used to shoot the ball. In this PowerPoint, I will be discussing the different aspects of numerical models, linear motion, force, stability and instability, and finally methods of data collection. Kinematics are a branch of biomechanics that work with motions or movements. You can measure this using the sum of mass times acceleration. Whereas kinetics are a branch of mechanics that deal with actions created by different forces. A force is a push or pull upon an object, which will be explained further later on in this PowerPoint. A linear motion is a forward motion along a straight line. For example, a basketball player running straight into the key to perform a layup. When shooting the layup, the ball will experience an angular motion as it is pushed out of the player's hands and spins off the backboard and down into the net. An example of a projectile would be a point guard shooting a three-pointer. The player creates a velocity to push the ball up into the air, and then gravity creates a gravitational pull to bring the ball back towards the ground as it falls through the hoop. Numerical models take time and are very expensive to create, which is why it only tends to be expert facilities that have the technology to do this, which means that it's only really professional athletes that use this. Numerical models can be created through books, newspapers, or computer images. These are all used to gain the data that is needed. They can also be made by watching elite performers and comparing the performance to your performer or client, usually a lower level athlete. I'm going to be talking about one way to create a numerical model. The method I will be discussing uses video cameras. To do this, you must make sure that all equipment is calibrated. This is to make sure the results are accurate and precise as possible. Accuracy refers to measurements and equipment. You can use a goniometer to measure angles at the joints. You can then use the equipment you have measured and calibrated to record the movement. This can be in 2D or 3D. The downside of a 2D model is that it's less accurate than 3D. The positive side of a 2D model is that it's a lot cheaper, as there are free apps available for lots of mobile devices. The downside of a 3D option is that it's very expensive and the software will only work on specialist equipment, which is why this option is mainly available to the more professional area of the sporting industry. The camera must also be capable to have certain settings adjusted when filming. When filming motion, you need a high-speed camera. This means it needs to be able to produce more screens per second than your average camera. Also, a fast shutter speed is better, but the downside of this is these don't tend to allow much light. The focus also needs to be on a manual setting to make sure you get clearer footage. Scalars are a value that has a magnitude. For example, how big, far, or even how fast something travels. Things such as speed, distance, mass, inertia are all scalars. Vectors are magnitude and direction, so how fast up or down an object travels. The following are all vectors: displacement, velocity, acceleration, deceleration, weight, and momentum. Speed and velocity are used to describe how fast an object is going. Speed is the rate of change of distance. Velocity is the speed of a body in a specific direction and is the rate of change of displacement. distance and displacement. An example of this would be when a basketballer shoots a basketball into the hoop. The distance the ball travelled could be 20 feet due to it travelling up to the hoop and landing back onto the ground, whereas the displacement of the ball would be measured from where the ball was thrown to where the ball landed, from A to B. This would usually be an entirely different result. As displacement is a vector, it has a magnitude and direction. If the direction is positive, then it will have a plus sign, and if it's negative, then yes, you guessed it, there will be a minus sign. The plus and minus signs on a vector indicate direction of travel. Minus indicates backwards, and a plus indicates forwards. Acceleration is the speed an object changes its velocity. It is also a vector quantity, which means it requires a direction. This is measured in m/s/s, which means meters per second, or meters per second squared. For example, when a basketball team wins a rebound, a point guard might accelerate from a jog to a sprint to make a break and potentially beat any defending players to the basket. Inertia. This is Newton's first law. Newton stated that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. An example of this law would be when a basketball is placed onto the floor. It wouldn't move unless it was acted upon by an external force, such as a player's hand. Forces. All motion is caused by a force, whether it's a pushing or pulling motion. Forces act on objects. For example, when you shoot a basketball, a gravitational force causes the ball to drop after the initial force, propelling the ball into the air. When you drop a basketball, the ball's weight drops due to gravitational pull. The floor then applies a normal reaction force, which pushes the ball back up, causing it to bounce. Horizontal force equals air resistance plus friction. Internal force is a muscular contraction. For example, when a shooting guard passes the ball using a chest pass, his triceps contract concentrically, creating an internal force to push the ball to another player. Vertical force equals weight or normal reaction force. And external force equals air resistance, gravity, and also friction. Forces are measured in newtons. You can use equipment such as a force plate to give a reading on the amount of force applied, but force plates actually measure the ground reaction force. For example, if a basketballer was running across the plate, it would measure the force pushing against the plate's foot, not pushing down. Forces can have many effects on an object. It can make a resting object move, for example picking up a basketball that's at resting. It can make a change in direction, for example when a basketballer is running straight then sidesteps to another direction to get around a defender. Acceleration, such as a player going from a jog to a sprint, and deceleration, which could be a player sprinting then decreasing into a jog. And finally, it can cause objects to change shape. For example, when a basketball is bounced, the area hitting the ground flattens slightly for a split second. Newton's laws. The first law concluded that everything at rest or moving with constant velocity in a straight line will continue in that state unless acted upon by an external force exerted upon it. The second law stated that acceleration of a body is proportional to the force, causing it and the acceleration takes place in the direction in which the force acts. And finally, the third law stated that to every reaction there is an equal and opposite reaction. Eccentric force is a force whose line of application passes outside the centre of mass of a body, causing the resulting motion to be angular. Direct force is a force whose line of application passes through the centre of mass of a body, causing the resulting motion to be linear. Impulse causes a change in momentum. This is mass times velocity. For example, pushing down on a ball when dribbling. To work out an impulse, you must do a sum of the average height times average time. Momentum is defined as the quantity of motion possessed by an object. To work out momentum, you must do a sum of mass times velocity. Stability. An example of this would be how stable a basketball player is when boxing out in the key. There are ways to increase your stability, such as lowering your centre of gravity and widening your stance to make a wider base to support your weight. The centre of mass is where the body remains balanced in all directions. Base of support is the area underneath an object containing every point of contact with the surface below. Line of gravity is an imaginary line drawn from the centre of mass down vertically to the surface below. Here is a table showing the results of a practical assessment we did at the university. This table will be analysed and described in 6.4. These are graphs that have been created using the data found in the table. These will also be analysed and described in 6.4.